Welcome to this video on the continuous uniform distribution. Statistics 2, S2. So here we have a random variable that has a continuous uniform distribution over a given interval. Now what you will notice on these is sometimes written as, say, x is distributed uniformly between the values of a and b, or in the interval, across the interval a to b. Okay, now in terms of its p.d.f, this will look something like this, and we have 1 over b minus a in here between the range of a and b, and obviously outside of that is nothing. And in terms of a diagram, which is the easiest thing, I tend to use a lot of diagrams for this, we get a rectangle. Sorry, it's terrible drawing there for my sketch, but a rectangle like so between a and b. Now this is the easiest way to think of it. It sometimes is called that kind of rectangular distribution. And what you can see here is that we have between a and b, and we know that this area must total 1. Therefore, if you worked out the distance of between a and b, which would be b minus a, to get the whole area to total 1, you would then need this height of 1 over b minus a. And obviously you think of the other way that works. If you multiply this by this length is b minus a times 1 over b minus a, you get 1, which is the area of this rectangle. And what I would say is that when we're dealing with these, in some cases it's easier to look at the diagram than it is to think of some of the rules of probability that you did last year, you know, when you were looking in S1. Now, I won't go through actually working these out. You can have a look at your notes and you can find other videos on that. But I'm just going to state them. Your mean, your expected value, E of x, is just simply a plus b over 2. Your variance of x is b minus a squared over 12. And then your c.d.f, or capital F, if you remember it that way, that's going to be x minus a over b minus a. And that is obviously between a and b. Okay, where obviously nothing below a and only probability of 1 when we go above b. Now, just before we get into some examples, a couple of things to note. The main one being that these type of questions will often look like a normal p.d.f, c.d.f type of question, but spotting that it is a uniform distribution will make your calculations so much easier. So finding E of x, the variance of x, you can do it the way that we did in the previous unit. Okay, but spotting, like I said, spotting it's uniform makes your life so much easier, quicker, and at the end of the day in your exam, time is one of your biggest enemies. So anything you can do to speed that up obviously is a welcome bonus. Now let's have a little look at a couple of examples. So here we have the continuous random variable x, and it's uniformly distributed 2 to 6, and then we've got to find these. So the first thing I'm going to do is I'm just going to do a very quick sketch just to make it a bit more visual. So it's rectangular, it's between 2 and 6, so then I can do 1 over b minus a, or 1 over 6 minus 2, which is a quarter. So the height of this has got to be a quarter. And that's f of x, and that is x. So doing that just to make it a bit more visual, I like to do it especially for questions like this given that here, which we'll get on to. I just think it makes it a little bit easier. So here for the first one, we want to find the probability 3.1. So x is between 3.1 and 5.6. And if I think of my diagram, say 3.1 is there, 5.6 is there, and this area in between. So that area is simply going to be 1/4 the height of the rectangle, the height here, multiplied by the length. And the length is going to be our 5.6 minus 3.1. And that gives us 5/8, or 0.625 if you want it in decimals. Okay, see how easy that is? Because all it is an area of a rectangle. Makes our lives so easy. Let's have a look at part B. So here we have the probability that 2x is less than k minus x, and we know that this is going to be equal to 0.1. So the first thing I want to look at is this inside here. So I'm going to do that over on the side, and I'll just change the colour into purple just out of the way. So 2x is less than k minus x, 3x is less than k, or x is less than k over 3. So that's what I'm going to go with. So now we've got the probability that x is less than k divided by 3, and we know that's going to equal 0.1. So thinking on my diagram, we'd have some value here which is our k over 3, and that area has got to be equal to 0.1. So if we're thinking of the area of a rectangle, the height is 1/4 multiplied by the length, which is k over 3 minus 2, and this must equal 0.1. So that means I've got k over 3 minus 2 equals 0.4. So k over 3 equals 2.4. So k is going to be equal in 7.2. And that's the first two parts of this one done. Let's now have a look at part C, which is where people tend to find or have the most difficulties. So here we have the probability that x is greater than 5, given that x is greater than 3. So there is two ways of doing this, and I'm going to show you the way I tend to do it, and probably a more kind of traditional way of doing it. So first, let's just enlarge this diagram to make it a little bit easier. Now, x is greater than 3. So what's happening here is x is becoming greater than 3. We know that happens, it has to happen. So, what we're basically doing is we're eliminating the rest of this probability, aren't we? It's no longer between 2 and 6, it's now between 3 and 6, which also means that won't be a height of 1/4. And then we're saying, right, we know that x has to be greater than 3, and we want to know when it's greater than 5. Yeah, so greater than 5, it's just that total fraction. So we're looking at this distance here is 1, this distance here is 3. So for part C, the probability where x is greater than 5, given that x is greater than 3, is equal to 1/3. Nice and easy. Hopefully that makes sense. Now, as I said, I'm going to show you another method. So that's the way I tend to do it, just by looking at it's a probability over a probability essentially. Let's look at it using the formulae that we learnt during S1. So probability where x is greater than 5, given that x is greater than 3. So this is a formula, would be the probability of where x is greater than 3 intersection x is greater than 5. So that's the intersection where these two obviously intersect. And that will be all over the probability where x is greater than 3. Now we know that the intersection of where x is greater than 3 and x is greater than 5 would just be x is greater than 5, isn't it? You think of, just imagine the rest of my diagram here, you know, greater than 3, greater than 5, where they intersect is only greater than 5. So this would be the probability where x is greater than 5 over the probability when x is greater than 3. Now, if you think back to the original one, you know, greater than 5, greater than 3. So the probability where x is greater than 5 is going to be 1/4. And greater than 3 is going to be 3/4. Just thinking of the area here, 1 times 1/4. This distance is 3 times 1/4. Now you can see here from my fraction rules that dividing by a fraction is the same as multiplying by its inverse, and you can see the 4's would cancel, leaving you 1/3. So that's me doing it completely algebraically there, just with a little bit of diagram for a little visual aid. Hopefully that does help and make a little sense. But let's have a look at a second example now, so we can look at the mean and the variance. So here we have a continuous random variable with p.d.f, and you can see here we've got 1/10 between 2 and 12. You'll notice these should work out as well, you know, distance of 10, height of 1/10. So write down the name of this distribution. Well, it's quite simple. It's going to be a continuous, sorry, concentrate on my spelling there, uniform distribution. So we'll fit it in, distribution. There we are, just about fits it in. And that's all you need to do there. It's quite a common question. It's about whether you spotted that it's a uniform distribution. Now let's have a look at part B. Now for us to do part B, we've got a new variable y. So this is as if it's been coded, if you remember back to S1. So what we have is, first thing we want to do is find e of x. Now this is b, oh, I went to do b, I'm going to say this is a plus b over 2. So in this case, 2 plus 12 over 2, or 7. Once I've done that, I can go ahead and find e of y, because e of y is just the same as e of 20 minus 2x. And if you remember back to S1, this will be 20 minus 2 lots of e of x. So we've got 20 minus 2 lots of 7, so obviously 14. So there we have that value as 6. Nice and easy, hopefully. Now, part C, we can see we've got here the probability that y is less than 4. So that would be the probability that 20 minus 2x is less than 4. And what we really want to do here is just sort out what's going on inside. So, you know, if I just rearrange this, take 4, sort the 2x out, we're going to get 16 and 2x there. Dividing by 2, we have 8 and x. Or a better way would be to write x is greater than 8, isn't it? Now that we know what we're trying to find, if I think of a diagram just to draw this out for you, we've got between 2 and 12, 1/10 as a height. We want greater than 8. We're looking for this area. So 12 minus 8, which is 4, gives me this length here. 4 times 10, 1/10 is 4/10 or 2/5. So So we've got 4 times 1/10, which is our 2/5. Nice and easy, hopefully. Now let's deal in part D. So we have the probability that y is greater than 4, given that x is less than 10. So we want to turn this into the same thing, don't we? It doesn't make any sense as it stands, so we need to make a few changes. So what I'm going to do is turn everything in terms of the variable x. So we know that y is 20 minus 2x, and that's greater than 4. We have x is less than 10. Now we've already dealt with this 4 here, so we know what's going to happen. Obviously the signs are a little different, but we do know that this is going to end up becoming x is less than 8. And we know that because when this one was less than 4, we had greater than 8. So greater than 4, less than 8. Just saves myself a little bit of time there. Now this is what we want to find out. So I'm going to do it my way, just have a quick little look at my rectangle. So I got 2 to 12. Now we find in the probability that x is less than 8, given that x is less than 10. So what that means is less than 10, this bit now is gone, doesn't exist. I now have a distance of 8, and I want to know what portion is less than 8. A bit confusing. And here it is. So I've got a distance here of 6, and my overall distance was 8, so we got 3/4 there. Remember that alternatively, I could find this with the intersection. So x being less than 8, intersection with x is less than 10 over the probability when x is less than 10. And that would give me, if I did it this way, I'd have 6 over 10 for my intersection, and then we would have 8 over 10 for my probability when x is less than 10, and we can see that's going to give me 6 over 8 or 3/4 as well. So it doesn't matter which way around you do this, you will get the right answer as long as you follow logical steps. And third way of doing it would be that you could, instead of this is obviously our variable x, we could actually find this in terms of its continuous uniform distribution y, and work from that. So we could use this to replace our 2 and our 12 with our limits for our y, our range of values, and we can do it that way. Not too difficult at all. And finally, part E, let's find the variance of y. So first you want to find the variance of x, which is b minus a squared over 12. Remember, you're writing these formulas down or formulae down every time you use them, not because it's going to get you any marks, but because every time you use it, it's going to stay in your head a little bit more. So constantly writing it down means that you'll never actually have to learn it, because you would have learned it as you were doing the questions. So it's a good practice to write these down as you go along. Anyway, we end up with 12 minus 2, which is obviously 10 squared, so we get 100 over 12, or 25 over 3 there. Now, variance of y is going to be the variance of 20 minus 2x. Now, if you remember from this, variance doesn't, the adding or subtracting values doesn't matter. We're looking at this one squared, so minus 2 squared is going to give me 4. So this is going to be 4 times the variance of x, or 100 over 3. And there we are done. Hopefully it's been quite straightforward so far. Stick around, try some of the questions. I've got 7 questions for you. As always, I'll go through the answers at the end. And yeah, if you're new to my channel, or even if you've been here a while but haven't subscribed, don't forget to hit the subscribe button. And you know, if you are looking at following these current videos on S2, maybe hit the bell icon, notify you when the next video drops.